Hey guys, welcome to the final lesson in Chapter 10. We are going to do 10.6, Trigonometric Ratios. And we skipped 10.5 if you hadn't noticed. Alright, our objective for the day is that I can find and use trigonometric ratios, or just shortened to trig ratios.
We remember these by saying Chief Sokotoa. He's an old Indian tribal chief. It'll make sense in a minute. Chief Sokotoa. Sokotoa. Love Chief Sokotoa. He's my favorite.
Alright, so problem number 1 is just going to be finding trigonometric ratios. And before we even do that, we need to figure out what are these things that I keep talking about. So they are the sine.
Spelled with an E.
Yep. The shorthand version of it, we just drop the E and just write S-I-N. So it's S-I-N of angle A, S-I-N-A. We've got cosine of angle A. We would shorten that to just cos, C-O-S. And we have the tangent of angle A, which we shorten as tan.
Mr. Bolin, what do you call a guy who is laid out on the beach all day?
I don't know.
A tangent.
Wow.
Okay, sorry.
Wow. You guys thought my jokes were bad. Alright, so this is where the SOHCAHTOA comes in. So when we're talking about the sine of an angle, we are looking at the length of the opposite leg over the hypotenuse. Sine opposite over hypotenuse, OH. The cosine of an angle is the adjacent leg divided by the hypotenuse. So ca, adjacent over hypotenuse, or attached over hypotenuse. The third one, tangent, is opposite over adjacent, which would be OA. So ca toa. Memorize that. So if we're going to try to find the sine, the cosine, and the tangent for angle E in this triangle. So our sine, opposite over hypotenuse. What is the opposite angle from letter E? Straight across, the opposite angle is, or the opposite side is 9. Over the hypotenuse, which is our longest side, which is 15. And we can reduce that to 3 over 5. Our cosine attached over hypotenuse, so it's the attached leg, 12 over the hypotenuse, 15. That reduces down to 4/5. Lastly, we have the tangent, which is the opposite over the attached, so that is 9 over 12.
That's what I meant.
Which reduces to 3/4. Okay. Letter B, we're going to do the same thing. Sine, cosine, and tangent for angle A in this triangle. So sine is opposite over hypotenuse. The opposite is 15. The hypotenuse is 17, and we can just leave that as is. Doesn't reduce at all. Cosine is the attached leg, which is 8, over the hypotenuse, which is 17. Again, we can't reduce. Tangent, opposite over attached. The opposite is 15, the attached is 8. Again, we cannot reduce. Okay. Letter C, we have what are the sine, cosine, and tangent for angle C in this triangle. So our sine is the opposite, 30, over the hypotenuse, 34. And we can reduce that to 15 over 17. Cosine of the angle C is the attached leg, so 16, divided by the hypotenuse, which is 34. And that'll reduce to 8 over 17. Tangent is the opposite over the attached, so opposite is 30 over the attached 16, which will reduce to 15 over 8.
This one's attached. How come we can't use this, the attached? How come we're only using this one as the attached?
Because 34 is our hypotenuse. Hypotenuse can only go when there's an h. All right, letter D. We've got what are the sine, cosine, and tangent of angle A. So the opposite is 48. The hypotenuse is 50. And that's going to reduce to 24 over 25. Our cosine is the adjacent leg, 14, divided by 50. And that reduces to 7/25. Third, tangent, we've got the opposite, 48, over the attached, 14. That'll reduce to 24 over 7. Okay. Not too bad so far. So moving on, we have problem number 2, finding a trigonometric ratio. And so for this, we are going to be using our calculators. We want to know what is the value of each expression. So we're going to use our calculator to find the sine of 38 degrees. Now, different calculators are set up different ways, but what we can do with our blue calculators in class, we use the second button, and we click on trig, which is right here, and we can see our trig ratio, or our trig function. So we've got the sine, so we just hit 1, type in our angle, 38 degrees, and hit enter. So our answer is going to be 0.615 or 616 approximately. All right. So for letter B, we've got the cosine of 51. So we're going to do the same thing. We're going to hit second and the trig button, and now we're going to use number 3, which is cosine. And we're going to do the cosine of 51. So the cosine of 51 is 0.629. Okay. Letter C, we're going to do the cosine of 61 degrees. And so that's going to be approximately 0.485. Letter D, we're going to use our third trig function. So we do second trig, and it is number 5 here in the list. So we're taking the tangent of 25 degrees, close it, and that is 0.466. Okay. Letter E, tangent of 79 degrees, you would just type that into your calculator again, and you're going to get 5.145. And the last one, the sine of 48 degrees, is 0.743. So this is just going to be done on your calculator. There is no work that you need to show for us. You just need to be able to plug it in and give us the correct value. So problem 3 is going to be finding a missing side length, and we are being told in our directions that we're going to round it to our nearest tenth of a degree. So this is where we're combining what we did in problems 1 and problems 2 into an equation to find a value. So we're looking at, we want to find the value of angle at, or the side x, and we know the hypotenuse, and we know an angle. And we see that that side x is the opposite side from the angle. So we're going to use our sine rules. So sine of 59 degrees is equal to the length of the opposite, x, over the length of the hypotenuse, 17. So So we're going to have to use our calculators on this. We're going to multiply by 17. So we do 17 times the sine of 59. So we type in 17 times the sine of 59, and we get 14.6. So we're rounding it to the nearest tenth. Okay. All right. And that is our answer. Letter B, we've got our x, and we see we have an angle of 40 degrees, and we have an opposite angle of 20 degrees. And we see our missing side is attached to our angle, so we are going to be using tangent. So the tangent of 40 is equal to the opposite, 20, divided by x. So what do we need to do to solve this? We cross multiply. Remember that back in chapter 2, second half of chapter 2 when we did a ton of stuff. All right, so we've got x times the tangent of 40 is equal to 20. And we're just going to divide by the tangent of 40.
Sorry, I was waiting for my brain to catch up.
Okay.
20 divided by second trig tan, which is number 5. Punch in 40 and hit enter and round to the nearest tenth.
So it's going to be 23.8.
My pencil's not working very well.
Okay. All right, letter C. We've got our angle is 51 degrees. We have one of our legs that's attached to our angle, and we have a hypotenuse. So we're going to use our cosine rule. So cosine of 51, cos 51, is equal to the attached side, 10, divided by our hypotenuse, x. So we'll cross multiply and then divide, and we're going to do, so we divide by cosine. Okay. So we find that we've got 10 divided by the cosine of 51 is approximately 15.9. Okay. Letter D, we have the angle is 27 degrees. Our missing side is attached to that 27, and we also know the hypotenuse is 20. So we have cosine of 27 is equal to the attached x over 20. Multiply both sides of the equation by 20, and we get 17.8 is approximately equal to x. Letter E, we have our angle is 60 degrees. Our unknown side is the opposite of that, and we also know the hypotenuse is 17. So we've got our sine rule. Sine of 60 is equal to the opposite, x, over 17. Type it into your calculator, and you're going to get that x is approximately equal to 14.72. Letter F, our angle is 53 degrees, and we can see that we have an attached angle, which is 12, and the opposite is our unknown, which is x, so it is tangent of 53 equals x over 12. Multiply both sides by 12, and x is approximately equal to 15.9. Okay, lastly is problem 4, finding the measure of angles. And these are going to be using our inverse trig functions, which is just using numbers 2, 4, and 6 in that trig list. All right, so for letter A, we are trying to find that question mark angle. And we know that we have an opposite side and we have a hypotenuse. So we write it as our opposite over our hypotenuse, 39 over 44, is equal to the sine of x. So this is where we change things up. To get rid of the sine, we do the inverse of it. So you just write x equals at sine, S-I-N, with a little -1 exponent. That's our indication that it is an inverse function. And so to type this into the calculators, we hit second trig, we go down to inverse sine, which is number 2, and we type in our fraction, 39 divided by 44, and we hit enter. And so we find that we've got 62.4 degrees approximately. Okay, there we go. Letter B, we've got an attached side to our question mark, and we have the hypotenuse of the triangle. So we're going to use our cosine rules. So we write cosine of x is equal to 24 over 36. So we're taking the inverse cosine. So it's going to be approximately 48.2 degrees. So we'll just keep rounding it to the tenths. Okay. Letter C, we have the opposite leg and we have an attached leg to our question mark. So it's 10 over 33 is equal to the tangent of x. So we take the inverse tangent of 10 over 33, plug that into your calculator, and you get 16.9 degrees. Don't forget degrees. Okay, make sure you guys don't either. All right. Letter D. We have the opposite side and we have a hypotenuse, so we're going to use our sine rules. So sine of x is equal to 26 over 33. Take the inverse sine, type it into your calculator, and you're going to get 51.99 or 52 degrees. 52 degrees approximately. Okay. Letter E, we have the opposite angle, or the opposite leg over the adjacent leg. So we're going to use cosine, or tangent. Tangent of x is equal to 13 over 16. So our inverse tangent of 13 over 16 is going to be equal to 39.1 degrees. Okay. Our last problem in this section, letter F, we have an attached leg and we have a hypotenuse. All right, so we're going to use cosine. Cosine of x is equal to 20 over 23. So we do the inverse cosine of both sides, and we get that the angle is approximately equal to 29.6 degrees. Okay. So this is a section that is going to be relatively easy for you guys since it is not very math intensive. You just have to be plugging things into the calculator. You just need to make sure you memorize what those relationships are, which is chief, SOHCAHTOA. Sine is opposite over hypotenuse, cosine is attached over hypotenuse, and tangent is opposite over attached. If you can memorize that, you can do well with this section. All right, we will see you all in class.